say that this is the talkative section today.
Point out, I get confused when everyone's that section. If the guys are talking, I'm like, oh, I get included. It's a lose-lose situation.
Alright, guys, you're going to want to focus because you're not going to know what's going on if you don't focus. I'm serious. Because there's about 8 or 9 vocabulary concepts that you have to know to be able to do the math that's coming.
Oh my word, what if you were
It is.
dropping stuff?
Everybody turn to page 456 now. 456. Because this will hopefully get you guys on track and focus. It's just a little way of saying, yeah, focus. Whoa! That was a little uncalled for and rude.
Yeah, very stupid.
Oh.
It's another way of saying, and I was like, we're stupid.
No, that's what I'm saying. God doesn't create stupid people. I don't believe that.
What was it? Like I said, you can't agree.
You just were born into sin and you chose to be stupid. Not you guys specifically, but like people that are stupid.
God, choose for us to
So we're predestined to stupidity. Okay. Alright. Concave. Anybody know what concave is? It's like a concave mirror would be one that light is shining towards the cave. Does that make sense? Okay, we'll talk about convex, I believe, tomorrow. That would be light shining to the opposite side of the cave. Okay? Now, concave spherical mirror is a mirror whose reflecting surface is the segment of a sphere. So what that simply means is this is half of a circle. There's your middle point. There's your total circle. This middle point has a name. We'll talk about it in a sec. All I'm trying to show you here is a concave spherical mirror is half of a circle. Now, could you have different curvatures for these concave mirrors? Could some things curve more, some mirrors curve less, and still be concave? Yes. Right? Now, unlike flat mirrors, concave mirrors can form what we call a real image.
Why?
Please pay attention. I'm going to go back quite a few slides to show you this. Here is a flat mirror. Flat mirrors cannot produce real images. They will always produce a virtual image, and here's why. When light is reflected off a flat mirror, the light never converges at one point. What I mean by this is when light reflects off the pencil and hits the mirror, when the light reflects off the mirror, that light never converges and hits at one point. Ever. Okay?
What do you mean by so lost?
So, light reflects off this, hits the mirror, and goes back this way. Light from the same point reflects here and goes this way. Are these two light rays ever going to converge?
No.
No. They will never converge. And so, if they would converge, it would create what we call a real image. And so this is why your brain makes up an image, because your brain says, I see light, it had to come from somewhere. And so what your brain does is says, I understand light is traveling in a straight line, and so it says, the distance it took to go from here, reflect to your eye, it said, oh, it had to come from the same distance behind the mirror to get to my eye from that location. So your brain creates an image.
Yeah, I still did that, but I get that.
That's why. So that means I don't actually look the way I think I look.
No,
you're still seeing the same light. Your brain is just creating an image of yourself behind the mirror because it says, I see myself, but I don't know where myself is coming from.
So maybe I'm more attractive,
right?
or maybe I'm less attractive.
No, convex will not. We'll get there, okay? I'm just trying to show you there's a difference. When I say a real image, what I mean is light is converging at one point that can actually create an image. When I say a virtual image is created when light never comes and meets at a point. And so your eyes still see the light, but since it never converges at a point, it doesn't actually create an image. Your brain makes it up.
So trippy.
Why do mirrors look horizontally when I'm vertically?
Good question. I don't know the answer to that.
But I saw a video, but I never watched it.
Yeah, I don't know.
Is that the same with photos?
Was what?
The whole reflection deal? How you're, I don't know, because like you take a selfie, and it's like, or like when you just have the camera facing at you, but you haven't taken a picture, and it's like you in there. Yeah.
That's adding a technological version.
Like, what if it is that?
If I were to say something, it would just be a flat out
Like, how do you
yes.
like,
So.
it's so weird.
I love theory.
Trans your
How
best.
cameras work?
No, he just said he did.
I could look it up.
Actually, no.
Okay, so back to this. We've got an idea. Now we should at least know when I say real image, what I'm referring to. When I say virtual image, what I'm referring to. Real images, the light actually converges at one point and creates an image. That's there. That you can, like, that's a real image. This projection here, this is a real image, and it can actually be projected, and you can actually see it. That's not my mind creating that. That's actually there.
So it's in a mirror.
Oh,
It's
it's because in the mirror, the things you see aren't there.
Yes.
That's why you can't see.
This is actually here. The things in the mirror aren't there.
So that's why it's virtual.
That's why I say virtual
Oh, that makes
image. Does that make more sense? All right. A real image is when light converges at one point and creates an actual image that is real. It's there. It can be projected onto something. A virtual image, light never converges, so your brain makes the image that's not actually there.
So does that mean?
That's actually not a mirror, that's a lens. We'll talk about that next chapter.
See, a lot of pops have all those tiny guys.
Is the image in the mirror actually there? Is it actually, is there a pencil behind the mirror? No. The answer is no. It's not. But this is actually here.
You can't prove that.
This is not a fake image that your body's created. That's actually there.
How do you know mirrors aren't an alternate reality?
I don't know. Okay, let's focus. I got a lot more stuff to get to. Yes? Through a mirror? Right. Guys, I understand. This is not the easiest thing to comprehend. Okay? A real image is an image where formed when rays of light actually pass through a point on an image. A real image is one that can be projected. For example, if light from here hits here at one point, it's going to reflect off here and hit my eyes, and that's why I see it right there, not behind a mirror. Because we know things don't just random. You can't have an object behind a mirror.
Alternate reality.
Wait, I think I got it.
That's how colorblind works.
What?
No. Like, the light goes, it's there, but your eyes can't pick up.
So there's no extra distance.
How can our eyes
I'm destined to be stupid, so I don't
There may be
care.
extra distance. No, it's going to be different. Depends on where the object is. Okay, let me show you this. Let me show you. This is a real image. Okay? Light is reflecting off this point at different angles, right? Light's going to reflect at all angles. Light's continuous. Okay? So light hits this, reflects, hits the mirror, or hits the concave mirror and reflects. Everybody see that? Light from the same spot reflects at a different angle, and then hits the mirror, reflects, and notice it went through the exact same point that the other light reflected at. So technically, I could say light would come here, and it would reflect like that. Light would go here, and would reflect like that. It would all come through the same point, coming from the same beginning source.
Why did it reflect like directly back?
has to do with how the curvature.
Does that mean
of
it's
the
a
lens-
real?
Yeah. That's the
It's a
angle.
real thing.
It's a
Dude,
real
if
one.
it's real, if the mirror is at all curved inward, that's all
So
you
basically-
need.
That's not true. These can create virtual images too.
What?
So basically, because the person is in
Since the flat mirror,
sorry,
it's like
I don't think I
it's all bending the light in the same direction.
Wait, it's okay.
It's like curved and all the
It
light.
can pass through the same points. Yes. Yes, absolutely. Okay?
So is
Now,
that?
this is happening at all points of this object, right? I'm just showing you one point of the object.
So if you were in a
Yes.
Is that like a
spherical mirror,
spoon?
A spoon would be the actual.
Is that real or?
Real spoon.
Real spoon. That, what you're seeing in the spoon is probably a virtual image. If you had an object that could, if you had a surface that could project a real image, you would also see a real image. You don't have a surface that could, you have to have a surface to project a real image.
So you're seeing a real image inside of a concave sphere. So like a.
No, that's a virtual.
That's virtual. I'm with you say.
It's not there in the
But if it's a
spoon.
point.
Guys,
Spoon is a real.
will you let me finish?
Why is it?
You guys are jumping to every possible outcome before I even had a chance to even explain one outcome.
Exactly.
Guys, I haven't even talked about it. Concave can produce a virtual image too, depending upon where the object distance is. Bear with me. Goodness. There's a few things that I need to define for you. You're going to want to write this down. When you see R, what that refers to is the radius of curvature. When you see C, that refers to the center of curvature. I will explain what these things are. Freak out. P,
Freaking out.
object distance. Q. You know, you're probably thinking, why do they use these variables? Well, they chose to, sorry.
oh,
Image distance. F. Focal point. H prime. Image height.
What under H?
That's kind of.
Just right before I.
H.
Oh, okay.
Object height.
It's good.
Because you're Q.
Because it's the image just.
Hell no.
I have no idea.
Is H the only one that actually has to do with someone else?
Hey.
Just the object.
Now a lot of these things are shown up here. Before I start defining them, I want you to have written them down. Okay. So, if I have a concave mirror, I said that there was a point that if I continued the concave into a full circle, that would be your point where you would get your radius, right? Does that make sense? So this point is called the center of curvature. So if I continued the whole circle, it would be the center point of your curve. Does that make sense? The distance from your mirror to your center of curvature is called the radius of curvature. And that should make sense.
Yeah.
Makes sense, everybody? Okay? Now we'll talk about object and image here. This would be the object. It's what you actually have. So the distance from the object to the mirror is going to be your object distance. Closer distance, further away distance. Make sense? You're looking at me like you're not catching that.
Is it just the very end point?
I don't understand.
It's going to be from your middle of your mirror to wherever your object is. So let's say that from here to here is 20 centimeters. Your object distance would be 20 centimeters. Okay? Image distance, this is your image. It's what gets reflected. The distance from your image to your center of your mirror would be the image distance. Let's say that's 15 centimeters. Yes?
Yep.
Focal point I'll explain in a sec. I'm going to skip that for now. Image height would be, so this little, this straight line that's right perpendicular to your mirror is called the principal axis. Okay? So that's your principal axis. I technically didn't define that. Okay? The distance from your principal axis to your furthest part of your image is called your image height. It's inverted, but from here to here would be your image height.
So would it be
From here to here would be your object height. Yeah?
So like, since it's inverted, will it be like, if you
There will be positive and negatives. We'll have to. I have a lot to get through. In fact, we spent so much time wasting time that we're probably going to have to take 2 days to do this. Congratulations. Got what you want. All right. Focal point. Get to that page in your book that I was talking about. I don't remember what page that was. 456. We will come back to this page. I just want to use this page right now to talk about what the focal point is. Okay? And I'm going to use image, or in table 4, I'm going to use the first little image in the top left corner. Everybody see the image in the top left corner? Okay? It's showing light rays coming in parallel. What has to be true about an object that has light rays coming in parallel? Any ideas?
like if it's a concave?
Any mirror?
Oh, well, if it's a flat
I'm not answering the
Does
question.
that mean the object is bigger than the mirror?
Nope. Good guess.
very far away.
Very far away. In order for light rays to come in parallel to each other, they had to have come from an infinite distance away, because if they're, like if an object's here, you're going to get not parallel, right? Because they're going to reflect at every possible angle. But if you're from an infinite distance away, the only way it's going to actually reach the mirror is if they're pretty much perfectly parallel to each other. For example, if I have light and I have the image on the end of the school building, the only way that light from me is going to hit the mirror way down there is if those lights are staying virtually parallel, because if they were at an angle at all, what would they do?
Miss it.
They would not even hit the mirror. Does that make sense? So what this is saying is, when you have light rays that come in parallel to a spherical mirror, okay, they will all come, I'm drawing a blank, what's the word I wanted to use? They all will converge. There we go. Okay. They all will converge through the same point. That point is called your focal point. And everybody see that all the light rays are converging through the same point.
So your focal point's where the real image is.
No. Well,
Because if that's where they're all converging,
normally I would say yes. In this case, you're probably only need a very small fraction of the light, because it's so far away, that's actually going to converge. So I'm not sure if you'd see part of an image. I really don't know. But in theory, yes. Anytime light converges, that's where a real image will form. Yes, absolutely. But I don't know how that plays if it's an infinite distance away, because we're talking theory here.
So you said it's where all the light rays
Converge. When I say converge, it means they're coming together at a point. Yes, they're meeting. All right? Now, obviously, we're talking infinite distance away. What is infinite? Okay, they're just trying to show you that if you have light coming in parallel, the focal point is where they would converge. We're actually going to talk about if you have an object at the focal point, you don't even see an image. We can look at it. Why don't you guys look at number 5. When you have an object at the focal point, what actually ends up happening is the light hits the mirror and never converges because it reflects a parallel. If you have light reflecting parallel, will they ever converge?
No.
Will your brain even be able to converge it behind the mirror? No. So if you have an object at the focal point, have you ever heard the blind spot when you look in your mirror in your car?
Yeah.
That's what that is.
How about do that with a spoon?
In theory. Okay? When you're at the focal point of a concave mirror, you will not see a real or a virtual image. Because if light's parallel, you couldn't converge it behind the mirror or in front of the mirror. It will never converge.
You just see nothing?
Well, that's a spherical mirror. Flat mirrors don't have focal points.
That's basement.
Have you ever seen the movies?
I suppose.
We gotta go to the.
Yes, I suppose. Yeah, I mean, if you had a huge spherical mirror, if you sat at the focal point, you wouldn't be able to see yourself in the mirror.
Oh, that'd be cool.
You wouldn't see you would see nothing. I mean,
I
Actually
like
see
that.
God.
That's not a bad thing.
It's just great.
that is so a valid answer. How is that not a valid answer?
What if
That is so bad. You reach the
Yeah, you don't like it. There's a difference. Okay. A couple other things I want to write here for you.
One or
Why is F on that picture not for the images?
What?
Why is F not where the focal point is?
Yeah.
F as in the little thing.
Oh,
at the bottom
here?
of it? Yeah.
That's the focal point.
Why is it
Wait,
not
why is it-
where that? Well,
why
that's
is
all
it
effects
like
then.
Why is it what?
That's
Why
not
is it?
what the
Because
light
we're
is.
not at an infinite distance where the
Oh, okay.
rays are coming
It's
parallel.
only at the focal
Yeah, that
point.
makes-
When you're at an infinite distance away,
Because-
light is coming in parallel.
So it doesn't always converge at the focal point.
No, it only converges at the focal point at an infinite distance.
Okay.
What's F regularly?
Because, guys, in order to form a real image, it has to converge. And it's not always going to converge at the focal point. For example, this is where it converges. That's not the focal point. The only time light will converge at the focal point is when the object is an infinite distance away and light's coming in parallel. This is not an infinite distance. That's really close.
So when does
Why is
it
it not
make
converging?
when does it make a virtual
I
image?
feel like I just said that.
If light is coming from any axis.
Because like if I get it,
There's only one point that's called infinite distance, right?
Yeah, I'm just confused because you said that the focal point from an infinite distance when they all.
Okay.
The infinite distance. So
The focal point is one spot.
Yeah.
These all
Okay.
infinite?
Right? And we know what the focal point is if we take light from an infinite distance and shine it at a convex or a concave mirror. Okay? Well, the focal point never changes for a mirror. It's one constant place that gets determined from an object at a far distance and coming in parallel. So the focal point is this: every mirror has one focal point.
So it's just, it doesn't depend on the size of the mirror, like.
Yeah, the curvature of the mirror, the size of the mirror. Absolutely.
When does it make virtual ones?
Okay, that was-
Not distinct.
it's really close.
So you were thinking all light has to converge to the focal point.
That's,
Okay, that, I misspoke then, maybe I was assuming too much.
When you're real close to a spoon.
Sure, yes, the only time light will go through the focal point is when you're at an infinite distance, and there's only one focal point for every mirror. Depending upon
Might
what-
you light will find a blind spot for a spoon.
Light rays are really
I
hard.
love being
Everything is, that's all I want.
Okay, so like if you have an object at an infinite distance, the only way the light that reflects off the object is if the light is virtually parallel to the wall.
What is that?
Yeah, so like, you're gonna have light scattered all different directions. You got here, right? But if you're in a different way, all of these other places disappear. I have light coming off at any angle not perfectly straight, at an infinite distance, that's not going to hit the mirror.
Okay. So it's only like the other rays are going to get
And that's why when wouldn't that mean that that's
What happened?
What happened? Well, it's only part of the light rays.
Shane, my mom was really cool.
I like breaking. Emma!
Was that on Thursday or?
Oh my goodness.
Jebediah.
Worksheet, amen.
You may not think this is an amen.
Nope, probably not.